And on the first 7 problems, all we're doing is factoring. So what goes into 24 and 30 is 6. So that simplifies the top to 4 and the bottom to 5. The x's will stay on the bottom with an x squared, 1y on top, 8 on the bottom, so I'll have 7 left on the bottom, so I'll have 4 over 5x squared y to the 7th. For number 2, the 4's go away, the x on top goes away, I get 1 left on bottom, so it's 1 over x. Number 3, 2 goes into 4 2 times, the x's on the bottom go away, I get 1 left on top, the y's on top go away, I get 1 left on bottom, so I've got x over 2y. Number 4, I can factor a 3 out of the bottom, so that gives me 21 over 3 times 2x minus 3. Then the 3 goes into 21 7 times, so I get 7 all over 2x minus 3. And then number 5, I can factor 3 out of both the top and the bottom. X minus 4 over 3 times x plus 5. The 3's go away, so I've got x minus 4 all over x plus 5. If I factor the top, I've got, let's see, x plus 8 times x minus 6 all over x plus 8. Cancel, so my answer is just x minus 6. And then the last one, I think I can just factor the bottom, a 7b out of it, and I get b minus 7, so I've got 1 over 7b. Okay. So today we're moving on to just multiplying and dividing rational expressions. So a rational expression, I think we already talked about it, but it consists of a polynomial divided by a non-zero polynomial because we can't have a 0 in the denominator. So all of those are examples of a rational expression. 3/4, x over y, 9 over a plus b. Any of those are polynomials. The product of a rational function is you multiply the top times the top and the bottom times the bottom, where neither of the bottoms can equal 0 because you can't have a 0 in the denominator. And quotient, how I divide fractions, right, is I take the reciprocal of the second one, and then it becomes a multiplication problem. So basically, I'm going to flip the second fraction, and then it becomes multiplication. Any questions? Okay, it's just like multiplying and dividing regular fractions without variables. It's exactly the same thing, only it's just a little harder. Okay, so the main thing when I'm doing this is that I want to factor. So I'm going to factor. We need to make sure we're factoring everything. So that's what we're going to do first, is we are going to factor everything. Everything gets factored, top, bottom, everything. And then we'll multiply it together. So I'm going to start there by factoring. So out of the top, I can factor 7, and I get x minus 2. And because it's multiplication, it's going to be top times the top, so I'm just going to combine everything together on the top. And this term, I don't really have to do a lot on this one because the multiples of 5 are 5 and 1, and the multiples of 1 are 1 and 1. So it's pretty, this one has to be a 5x and an x to get 5x squared, and then what multiplies to be 1, well, that's a 1 and a 1. So I don't really need to do the box on this one because there's only one choice of where numbers go. So that one's pretty easy. And then x squared minus 4 factors 2, x minus 2 times x plus 2. And then I think I take a 7 out and I get 5x plus 1. And now that everything's factored, now I'm going to try and make 1. So there's a 7 in the top and the bottom. X minus 2, 5x plus 1, and that's all. So I get left with x plus 1 divided by x plus 2. And that's my answer. Any questions so far? Okay, we're going to do the same thing on the next one. The next one's a little bit harder because we've, for one, it's been a while since we've factored cubes, and I'm just going to remind you really quick that, remember, if I have a cubed minus b cubed, that factors to a minus b times a squared plus a times b plus b squared. So the first expression here will factor to, this is x cubed minus 3 cubed, because 27 is 3 times 3 times 3. So that means I'm going to have, what am I going to have? X minus 3 times x squared plus 3x plus 9. And then the second one, let's see, I can factor out an x cubed first. And then I get left with x squared minus 6x plus 9. Okay, great. So x cubed. And then -3 and -3. Okay. Any questions? Are we okay? All right. And then the bottom, let's see, and this one I can factor out an x squared, and I'm going to get x squared minus 9. Beautiful. So that means I've got x squared times x minus 3 times x plus 3. And then the second one doesn't factor, so x squared plus 3x plus 9. Now I'm going to make ones. X minus 3, x squared plus 3 plus 9. Okay, so I should have x times x minus 3 squared all over x plus 3. Okay, any questions? You guys have 4 problems to do. Please go ahead and get your answers in the chat box. I'm going to give you. So I'm going to factor everything. Actually, on the first one, I kind of really don't need to factor, because if you just look at it, you can kind of see if I multiply it right, I can kind of just put parentheses around these. I could factor the 2x plus 6, but I have a 2x plus 6 on the bottom and the top, so that makes a 1. So I can just kind of cancel that out without factoring it. And so I get x minus 7 over x plus 5. Done. And then kind of the same thing on B. If you look at B, it's got an x plus 5 on the top and the bottom. I do have to kind of factor this one. And it's like, if I factor out a 7x, I get left with x plus 1. And that's what becomes there. And then I can make ones. So the x plus 5 goes away. And what I get left with is x minus 6 times 7x times x plus 1. Done. Okay? So we're factoring every single time. So if I'm looking at this one, again, I just happen to notice that this term and this term is the same. So I'm not going to factor that. If I don't have to factor it because I have the same thing on the top and the bottom, I'm not going to factor it. That just takes a little bit more of the work away, makes a little bit less work. But I do have other things that I need to factor in this problem. So I was saying that you need to factor each numerator and denominator. So I'm going to look at each one individually and factor it, except for the 3x minus 30, because I already know that I'm going to cancel that out. So I'm going to factor this one here, right? So what multiplies be negative 5 adds to be 4. That would be 5 and negative 1. And then I'm going to factor this one. What multiplies to be negative 35 and adds to be negative 2. I think that's negative 7 and 5. So if I write all my factors out, I should have 3x minus 30 times, in my numerator, I'll have x plus 5 and x minus 1. And then in my denominator, I'll have x minus 7 times x plus 5, and then times the 3x minus 30. Okay? Is everyone okay with that and how I got all those terms? Especially those of you who said you were confused. Okay, now I'm going to make ones, right? So I have a 3x minus 30 on top and bottom. That makes a 1. And then I have an x plus 5 on top and bottom. That makes a 1. And then whatever's left is your answer. So I've got x minus 1 all over x minus 7. Done. And again, for number D, nothing in common on this one. So I'm just going to have to factor everything, and I'm going to factor each individual term. Instead of looking at it as a one big, huge problem, I'm going to look at it as 4 individual little problems, so I can factor each one individually. So in the numerator here, I'm going to factor a 4x squared out, and I should get 3x plus 1 left. And then in this one, I'm going to factor a 3 out, and I should get x plus 10 left. And then in this one, I need 2 numbers that multiply to be negative 40 and add to be positive 6. So that should be 10 and negative 4. So that should be x plus 10 times x minus 4. And in this one, I can factor a 3 out. So that should be 3x plus 1. And then I'm going to make ones again. So the 4 for 3x plus 1 and 3x plus 1, the 3's, and the x plus 10 and the x plus 10. And then whatever's left is my answer. So I've got 4x squared all over x minus 4. Okay? Questions? Are we okay now? Does that make a little more sense? So basically, all you're doing to multiply this is factoring. Factoring, 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 factoring. Okay? And guess what we're going to do to divide? Same thing. We're going to factor. And I think that's what we're going to next, is dividing. And we're going to factor. The only thing different is when I'm factoring, these two flip. I take the reciprocal of the second one. So I'm going to factor the first one. I'm going to factor this one. And that factors to, what does that factor to? 5x plus 2 times 5x minus 2. And then this flips, so this becomes x plus 3 over 2 minus 5x. So this becomes x plus 3. And it's times. And then the bottom is x plus 3 times x minus 3. And then I need to factor this. I'm going to factor out a negative 1. And then that becomes 5x minus 2. And then I have a 5x minus 2 and a 5x minus 2, x plus 3, x plus 3. And
why don't you factor out the minus 1?
Because if I didn't, I wouldn't have a like term on top and the bottom.
Okay.
Does that make sense? Because this is 5x minus 2 and this is 2 minus 5x, so they're not the same. If I factor out a negative 1, my signs change on this, and this becomes 5x minus 2. So now I have a like term that I can make a 1 out of. That was a good question. So my answer becomes 5x plus 2 times negative x minus 3. Now with the negative, sometimes you'll see them actually multiply that negative through. So you'll see either one of these answers. You'll either see this one will say 5x plus 2 times negative x plus 3, or you'll see the one that says negative 5x minus 2 over x plus 3. So in your multiple, if you get a multiple choice answer, like on your ACT, you'll see one of the 3 answers. And it can be any of those 3 with the negative if you have to factor out a negative. So just know it could be any of those. I've seen all 3. Okay.
I have a question about the third answer.
This one?
Yeah, so why if the negative 1 is on the bottom, then why do you make the top negative?
So think about it. I could actually have written this as minus 5x plus 2 over x minus 3. So the negative could go with the top or the bottom. Right? If your answer is 1 over negative 2, that's still negative 1/2, right? The negative could go with either the 1 or the 2. So it can either go with the top or the bottom. It doesn't matter. That fraction's still negative.
Oh, okay.
Does that make sense now?
Yeah.
Yeah. Good question. Okay. So same thing, right? So I'm going to flip these 2. So this becomes x squared minus 3x minus 10 over 3x minus 12. And it becomes times. So if I factor, I've got x minus 4 times x plus 4 times x minus 5 times x plus 2. And then in the bottom, let's see, that's x minus 5 and x minus 5. And if I factor 3 out, I get x minus 4. So x minus 4 and x minus 4, x minus 5 and x minus 5. So I should get x plus 4 times x plus 2, all divided by 3 times x minus 5. X minus 5. Ugh. Okay. Questions? All right. So sorry, I thought there was more problems on this page. So about the same amount of time. So, right, this one flips. So it becomes 1 times 2x times x plus 1 all over x plus 1 times 2. So x plus 1, 2, and 2. So that equals x. Nice, Jesse. And then B, again, we flip it, and I've got 10n times n squared minus 6n plus 8. And again, I didn't factor that because I realized that it's the same in the top and the bottom. So I just didn't factor it because I'm just going to do this. And if I factored it, it would still be the same. I just cancel the factors, so it's just easier just not to factor it. So I've got 10n over n minus 10. Although if you did factor it, you should get the same answer. It's 10n over n minus 10. So there's that answer. Then C, I am going to flip the second one. So the first one factors to x plus 6 and x minus 4. And then when I flip this, I'm going to factor out a 3x squared. So I should get x minus 1. And my denominator is going to factor to x plus 6 times x minus 6. And then x minus 4 times x minus 1. And then if I'm making ones, x plus 6s, the x minus 4s, and the x minus 1s, all go away. And I get left with 3x squared all over x minus 6. Yeah, of course there is. Emma, when you log back in, I'll just add you to the class, so that's fine. And then D again, I'm going to flip these. And then I get r minus 4 times 7 and r minus 9 times r minus 9. And then this first one factors to r minus 4 times r minus 9, and then I can take out a 9r squared, which will leave me with r minus 8. Ugh. Okay, so the 4s go away and the 9s go away, and I get left with 7 over 9r squared times r minus 8. Okay, questions? All right, so now we're going to go on to something that looks a little uglier, and it's not any harder than what we just have gotten done doing. It just looks that way. It just looks that way. So Mr. Call doesn't like that this is called complex fractions because in math, right, complex means imaginary numbers. But the word complex has other meanings. Complex means harder, right? More challenging also. So we're getting more challenging. For the multiplying and dividing, it's not really any more challenging than a division problem because all you're doing is taking the bottom fraction, flipping it, and it becomes a multiplication problem, just like what we just got done doing with the divide. So it just looks more, I guess it looks more intimidating this way when it's written this way. And that's why people have an issue with it. But just so you know, when we're talking about rational expressions and if them being complex, we will get complex answers, meaning imaginary answers with these. But when we're talking about complex fractions, basically we're just talking about these really weird, kind of funky looking fractions that that look like this. So here we go. So all I'm doing, right, is a fraction divided by a fraction. So what do? You flip this second one and it becomes multiplication, right? So this is x over 10 times 4 over x, which equals 4x over 10x. So the x's go away. 2 goes into 4 2 times, into 10 5 times. So my answer should be 2/5. Done. Okay? Questions on that? So, is there any questions? Or it doesn't make sense that it's a fraction divided by a fraction, so I'm flipping it and dividing. Flipping it and multiplying. Woo! Okay, so here's 2 problems for you to do. So I'm going to flip this one, right? So it's going to become times x plus 2 over x squared plus 4x plus 3. And so if I factor, I've got 2 times x plus 3 times x plus 2 all over 5 times x plus 2 times x plus 3 times x plus 1. And then I've got the x plus 3s and the x plus 2s. So my answer should be 2 over 5 times x plus 1. Okay? And then the last one, if I flip this one, it becomes times x over x minus 1, right? So I factor the top and I get x minus 4 times x minus 1 times x all over x squared times x minus 1. So the x minus 1's go away, this x goes away, and one of those x's go away. So I should get x minus 4 divided by x.